Hey Tigers, welcome to your digital reteach for work. This is the Texas Essential Knowledge and Skills 7.7a. In this TEK, it is your job to contrast situations where work is done with different amounts of force to situations where no work is done, such as moving a box with a ramp and without a ramp, or even standing still. It's important that you understand how you're going to get credit for this reteach. Please make sure that you're using the Cornell Note worksheet from your teacher while you watch this video. Take notes, answer the questions, and write your summary at the end. Show your completed Cornell Notes worksheet to your teacher. They will give you more information at that time about how to do the next retest. So first off, let's start with the idea of what is work. And it sounds simple enough, but in science it's got some more details. Probably the most important thing I want you to understand is anytime you're doing science and you hear the term work, start thinking math. You will always need to use the formula work equals force times distance. And that'll often just be represented as W equals FD. If you get a story problem with no numbers at all, and this does happen quite a lot, in a story problem like that, it's okay to make up some of your own numbers so that you can still try the formula. A good example of this would simply be is if a box does not move, okay, they didn't give you a number, that doesn't matter. If it didn't move, you know the distance is 0, and now you can plug that number in. Another example of this would be something like if a box moves with more force. Well, that means that you're just going to make the first number something small. I would use 1, that makes the math very simple. And then the second number, more force, just make it 2. It keeps the math very simple and it'll still help you understand what's happening to the amount of work. Now let's get this out of the way because this is always a big problem until you get this out of your head. What is not work? Here are 3 examples of what we do not mean by work. And the problem is we use this in our everyday language, and our everyday language does not always match the world of science. So if you hear somebody say, I drove to work today, right, that is not what we're talking about here in science. If you hear somebody say, I'm working hard and I'm sweating, maybe you feel that way when you're doing a workout, you're practicing for the football team, you're getting ready for basketball tryouts, you're working really hard. This is not what we mean by work in science. Or maybe you're just telling a teacher, hey, I'm working on my homework. Okay, once again, this is not what we mean by work when we are teaching science. Once again, go back to the formula. So here we've got 2 different examples that you can start to use the formula and get an idea for work. In the first example, we're going to try to get this gift or this box, and we're going to lift it 10 meters to get to the top of the table. And we're going to use 5 newtons of force. So this capital N is for newtons. That's just how much force there is. So if we lift this box up with 5 newtons and we move it 10 meters, after that, we just work out the formula. W equals force times distance. I had 5 newtons. It went 10 meters. 5 times 10, easy enough, is 50. And for work, we use the letter J. J is for joules. So this used 50 joules, and that is how much work that we did to get that box from the floor up 10 meters. So now if we use a smaller table that's shorter, if we use the same box, but we only need to go 5 meters. And this example is going to be a little bit different. Once again, start with your formula. Work equals force times distance. My force was 5, and it moved 5 meters. 5 times 5 is 25, so 25 joules. So that's how much work I did. So looking at these 2 examples, it should be easy to see that if I move the same thing but move it a greater distance, even if I'm using the same amount of force, I did more work. More work was done to this box over here to get it to the taller table. It took me less work to move the box to the shorter table. All right, so let's think about using a ramp. A lot of times ramps are used, and there's a very important reason why. And this is one of those things that you usually understand even without doing the math. But at this point, we need to start doing the math to make sure we know what's going on. So let's try to imagine first if you had to do this without a ramp. What if there was no ramp and you got to lift this piano straight up in the air 3 meters? Let's just say that takes you 100 newtons of force. So 100 newtons times 3 meters. So it's going to be 300 joules. That's how much work I do to move the piano straight up with no ramp at all. All right, so if I use the ramp, well, I got to go a longer distance. So let's say it's 5 meters, and these numbers are fake, but it still works. Let's say it's 5 meters to get up this ramp. So now my distance is 5 meters. The nice thing about a ramp, though, is it's easier on me. It's not as hard for me to push something up a ramp as it is to pick it straight up off the ground. So let's say it only takes these guys 60 newtons of force now, so it's less force than before. But check this out. This is where it gets interesting. 60 times 5 is going to equal 300. It's important that you understand that a ramp will make it easier for you. You're not going to need to use as much force. You're going to use less force. But what you got to understand, and the math proves it right up here, is you need to understand the amount of work that was done to the piano lifting it straight up, or the amount of work done to the piano moving it this way is still the same amount of work. You just use different amounts of force because the distance was different. So it's really important to understand that about ramps. All right, next up, let's look for a very important pattern for the work formula. In this example, I want you to look at this guy trying to lift these weights. He's not moving. He's not falling down. He's not rising them up. He's just holding them steady. Now, he could still be pushing really hard on the weights. He could still be pushing really hard with his legs. And let's just say he's using 200 newtons of force to try to lift these weights. However, if the weights are not moving at all, if they're not going anywhere, then the distance is 0. Now think about this. 200 times 0 is 0. So the amount of work he's doing to the weights is also 0. He is doing no work at all. This is a really tough idea for some students to understand, but this is where you got to plug numbers into the formula to make it easier. So to give you an example, if you go to example 2, let's say that this weightlifter is like, okay, I'm just hanging on. I need to start getting these to lift up. Let's try to lift even more. Let's try to press harder with our legs. Let's try to lift this up. Let's use more force. So let's say that he uses 300 newtons of force, but the weights are still not going up. So 0 meters is our distance. It's not moving. 300 times 0 is also 0. Is he doing any work to the weights? Absolutely not. So what's really important to remember here is that if the object is not moving, if the object has 0 for distance, then there is no work being done to that object. Even if you're trying harder and you're changing the amount of force you are using, no distance means that there is no work. Another example of this could be if you've tried to ever push on a brick wall. If I push on the brick wall a little bit and it's not doing anything, then I'm doing no work to the brick wall. And then let's say I really try to push hard. I'm using my feet, I got my tiptoes dug into the ground, I'm pushing as hard as I can on that brick wall, and I'm sweating. And I'm breaking out into a sweat, I'm losing energy, I'm using tons of force. But if the brick wall does not move, the distance is 0. And then whatever my force is times 0, that means there is no work being done to the brick wall. So that's it for your digital reteach. Please keep in mind with work, it's really all about that formula. And that's the easiest way that you can make a mistake is if you forget to think about it through the formula. All right, good luck on your retest.